Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the Cisco Networking Academy's CCNP implementing Cisco Enterprise Advanced Routing and Services, or ENARSI, version 8 course curriculum. In this packet tracer activity, we're going to be focused on EIGRP for IPv4, or as you'll sometimes commonly see it referred to, EIGRP v4. And this is packet tracer activity 2.2.1 from our course curriculum. Now, the first thing that we need to take a look at, because I am a huge believer in primary source material, is the RFC, or the Ietf request for comment on EIGRP, or Cisco's Enhanced Interior Gateway Routing Protocol. Now, I want to call your attention to a number of the names that you see listed out here as authors and contributors to this RFC. Most notably is Donnie Savage. Now, Donnie has been the primary maintainer, and I've spoken to Donnie multiple times. He has rewritten almost every line of code for EIGRP, and he has been the maintainer since right around 1994-95. And so, as you can see, he is the primary author of this RFC, which goes into great detail about this routing protocol. Don Slice is, again, another legend in the Cisco routing space. He is currently with Cisco Systems. Peter Paluk is also, again, another brilliant network engineer. And then you have Russ White, who is also a legend in the routing space. And so I don't know these two individuals here, right? But I can speak to the four individuals that I've mentioned. And with their contributions, this really makes the RFC primary source material. You have the individuals responsible for not just the creation and the maintenance and the upkeep of EIGRP authoring this document. You've got their insights into not just EIGRP, classic EIGRP, but for the new named mode, or 64-bit EIGRPs, it's commonly referred to, and we'll get into that. So this is a great document to get into, and I'm going to reference this document multiple times because we're going to talk about one of the major and probably one of the most important features of EIGRP from a scalability perspective that you will not find detailed here in the RFC. So RFC 7868, this is a must read if you want to master EIGRP and the concepts behind it. So let's dive into the packet tracer activity. And again, we'll move from the packet tracer activity on to physical Cisco routers because I'm going to show you some multiple ways you could accomplish what we're doing here. Now, this activity is really going to sort of walk you through the configuration steps that we're going to be doing and then have you kind of repeat certain things on the router. So let's go ahead and we'll start on router 1, which is where they have us starting. And so EIGRP is not a hybrid routing protocol, right? First and foremost, EIGRP is an advanced distance vector protocol. And the reason that it's advanced is because it uses more than hop count, and this is one reason why it's more advanced. The algorithm dual is one reason. However, it uses more than just the hop count to determine the best path. And we'll talk about the K metrics, right, or the K values, the composite metric values that sort of make up EIGRP's decision on which path is the shortest, i.e. least cost path to take in order to get from a source to a destination. And so let's go ahead and dive in here. We're in user exec. Let's get into privilege exec mode and into global config. And we're talking about classic EIGRP. And you'll hear classic mode or 32-bit mode. And what that means is that EIGRP v4 or EIGRP for IPv4 and EIGRP v6 or EIGRP for IPv6 are going to be different configuration stanzas, right? And so here we're focused on EIGRP for IPv4. So we would simply say router EIGRP, and then we've got this autonomous system number. Now, in order for an EIGRP neighbor relationship to form, an adjacency to form, the autonomous system numbers, the AS numbers, must match. If they don't match, an EIGRP neighbor adjacency will not form. And we're just going to use router EIGRP1 because that's really what the activity is asking for. Now, the range of numbers that you can use, you can see right there, 1 to 65,535. Now, it wants us to go ahead and say show IP route. I'm going to say do show IP route here because we're in the router configuration stanza in global config. And you can see that right now, all we're seeing are the local and directly connected representations of the routing table and what we have in the routing table here. And what they're asking us to do, and the question is, how can you tell the difference between subnet address and interface address? Well, the local entry with the L, that is your interface address. Whereas the directly connected network shows you the network ID and subnet mask. And so it's from here where you don't actually have to say do show run or, you know, go up and look at the addressing table to figure out, is it a /24? Is it a /30? What are we working with here? Because what we can do is we can look at this and then we can come down and simply compare that, yeah, the information we need for the network statements to enable the EIGRP process on the interfaces that are involved in this activity are listed out right here. So again, some people might say, you know, do show run and like, well, let me come down and look down here and see what is the dotted decimal subnet mask. Because maybe they don't want to do the conversion. You're not comfortable with doing the conversion from CIDR notation or slash notation, seeing a /30, a /24. Maybe you want to look here. But again, if you say do show IP route, everything you need is right there listed with that local, right? That's what that L stands for. And here's our, you can see right up here in the sort of secret decoder ring codes. And that's what that L is for. And so here's where we would put in our network statements. However, I notice, and again, Cisco best practice, things you want to be deterministic is we want the EIGRP router ID defined right up front before we start the EIGRP process on any of the interfaces that are involved. And I'm looking here, I don't see them having us do this anywhere. So we're simply going to set it to 0001. Now, what is the router ID used for? Because with distance vector routing protocols or advanced distance vector routing protocols, specifically EIGRP, the router ID has a different purpose and use than with a link state routing protocol like OSPF. And so with EIGRP, the router ID is not used to build a map or to represent this node's links in some sort of a link state fashion because EIGRP is advanced distance vector. It is not hybrid. And I'm quoting Donnie Savage on that. EIGRP is not a hybrid between link state and distance vector. So what it's used for primarily is when we're doing redistribution between EIGRP autonomous systems. Because if the router ID matches, and let's say I use the same router ID here on router 3, if I use 0001, router 1 and router 3 are going to think that there's a loop, right? Because they're going to be seeing EIGRP routing updates with the router ID that is their router ID, and that indicates a loop. So Again, primarily it's when we're redistributing between EIGRP autonomous systems. However, here we're not doing redistribution. We're just trying to set up the adjacency. The adjacency will form. However, you're not going to see the routing updates, right? So that's very, very important. Okay, so we're going to set the router ID. That is a best practice. Now, what are they asking for here? They want us to set up these network statements, right? So I'm going to go ahead and we'll go along with the network statements. We'll say 172.16.1.0, and then we use the wildcard mask, something that you should be familiar with from your CCNA studies. And that is one way to do it. Now, let me go out. I don't want to blow the activity up here. And let's actually finish up here. We'll say 172.16.3.0 with the wildcard mask for a /30. And then we'll do something similar here with a wildcard mask for another /30, 192.168.10.4. And that is not the IP address of the interface. That is the network ID for that /30 subnet, right? So there's the three network statements. They're now asking us to configure the LAN interfaces that don't advertise, so that they don't advertise EIGRP updates. Now there's a security concern more so than a performance consideration here. And so what they want us to do is they want us to passive or make passive that interface. Because if we make passive the LAN facing interface, that ensures that EIGRP hellos do not get sent out that interface. And what's the purpose of the hello? Well, the primary purpose of the EIGRP hello packet is to try to find other EIGRP speakers with which to form an EIGRP neighbor adjacency. Well, let's look out here on this LAN segment. Where are the other routers with whom I would be looking to form an EIGRP adjacency? Yeah, you got it. There are none. So we don't need the hello packets sent out on the LAN. Now, you can make the argument that, well, that's an optimization from a performance perspective because we're not sending these hellos out on that LAN. And yes, you could make that argument, and certainly that is a legitimate explanation. However, a better explanation is we don't want these EIGRP hellos being sent out on the LAN, because what if this guy right here is running Wireshark? He could then capture these hello packets, and remember, the threat, the insider threat, is typically greater than the outsider threat in some cases. So we don't want hello packets being sent out, EIGRP hello packets being multicast out onto that LAN segment that this dude could be listening for, and then he's going to see a lot of our EIGRP information. That's not something that we want. And so that is really, from a security perspective, I would say that that is a more important, better consideration for making the interface passive. And that's what we're talking about. Do not advertise EIGRP updates. Really, it's the hello packets that we're talking about. So that is the reason we would make that interface passive. Now, there's a couple approaches that we could take here. You can see that they have a say, passive interface, gigabit Ethernet 0.0. Now, you could certainly do it like that, and it's really going to depend on how many interfaces you are establishing EIGRP neighbor relationships on as to how you approach your passive interface configuration. So with this command, we make that single interface passive. Now, here are two serial interfaces over which we are going to be forming EIGRP neighbor adjacencies. So you could simply passive the one interface, and then all other interfaces would not be passive, meaning these other interfaces here would be sending hello packets because we've got the network statements that are enabling the EIGRP process on those interfaces, and they will send the hellos, and we want them to form the adjacency. There's another way to do it, and let me go out here to a real Cisco router. And what I could say here is I could go into global config and say router EIGRP1, and I could say EIGRP Router ID 0.0.0.8 because this is router 8, and I could say passive interface default. That makes all interfaces passive by default. And so then if there were interfaces over which I want to establish EIGRP neighbor adjacencies, I would know passive those interfaces, like serial 000 for this router here, router 8. Again, it's going to depend your approach as to whether you individually say passive interface gig 00, or you open up with passive interface default and passive everybody, and then pick off the individual interfaces you want to know passive, is driven by the number of interfaces that would not be passive. Because if I open up and say passive interface default, and router 1's got 15 interfaces over which we're going to be establishing EIGRP adjacencies, I now have 15 no passive interface commands I'm going to have to run. And that's going to be not just a pain and not just manual work. It's going to make the configuration stanza a little bit messy with a ton of commands in there that we said no passive on. So wouldn't it just be better to passive the LAN interface and then leave everybody else no passive, right? So again, there's multiple ways to achieve the same result, the same end result. You just need to figure out which is going to be better for you. And again, my rule of thumb is that I pick based on how many interfaces I will be establishing EIGRP neighbor adjacencies over. And if that number is greater than the number of LAN-facing interfaces, then I just simply pick the individual LAN-facing interfaces and say passive that interface, instead of passive interface default and then having to say no passive interface. All right, now they want us to disable auto summary. And that means auto-magically summarizing networks at the network classful boundary. Now you'll notice that they've got this note here. Prior to iOS 15.x, or the 15.x train of code, this had to be manually disabled, where you would say no auto summary. Now let's see if they give us points. We're at 32%, and they don't give us points, and that's okay. Because in most current versions, auto summary is off by default, which in current networks, that's something that you're going to want, is you want automatic summarization turned off. We don't want things to be auto-magically summarized. So let's come out here to router 8, which if I say do show version, is running 15.1 code, and actually you can see a little bit better up here, 15.14M12A. So let's say do show run section router EIGRP. And we look at the EIGRP configuration stanza for EIGRP1, and you can see that it doesn't show that auto summary. Now, there were some versions of 15.1 code where it would actually say here in the code auto summary, right, in your configuration stanza, and then you would have to come in and say no auto summary. And then if I rerun this command, let's take a look. Why is no auto summary not here? Why do we not see, and I'm not sure, let me do something real quick here. No, let's see, no router EIGRP 54321. I'm not sure why that's in there. No router EIGRP 54321. There we go. Because I didn't want that showing because it was kind of making it confusing when I'm saying do show run section router EIGRP. You've got the IPv6 process down here, but that's okay. We're interested in this here. I just wanted to get rid of that sort of redundant setup. So we say no auto summary, but it doesn't show up here. Why? Because it's a default, right? If I said auto summary and sorry, let's get back into router EIGRP1. If I said auto summary, and then we said do show run, pipe it to section router EIGRP, auto summary does show up, right? And again, we do not want auto summary. We want no auto summary, which means you should not see auto summary in here, because no auto summary for recent versions of the code of iOS is the default. In fact, the latest and greatest version of code I'm running here on these 3945Es, which is this 15.7.3M3 code, and you'll see the same thing. If I say router EIGRP1, and I say no auto summary, and let's say EIGRP Router ID 0001. Again, I'm just throwing some stuff in here so that we can see do show run, pipe it to include section router EIGRP1. Whoops, sorry. Not includes, I just want section. Sorry about that. Section router EIGRP1. You'll notice you don't see no auto summary, because it's the default. So again, I wanted to touch on that. I like that they've got this note in here. It's a command that I typically run out of habit when I'm doing an EIGRP configuration, just to be sure, because I got burned on this in early 15.x code versions where they told you, oh, auto summary is off by default, and then you would quickly find out that, well, no, in this version, we forgot to do that. It wasn't off by default. All right, so enough about auto summary. So now we're going to save the configurations. So let's go ahead and say end. We'll say write mem. And let's walk around to the different routers, and we'll do the same thing again a little bit quicker than we've done previously. So router EIGRP1, they want us to say no auto summary. And what about a do show IP route? Because from here, I've got all the information I need to go ahead and say network using that local 172, or I'm sorry, the directly connected entry 172.16.2.0, and that's a /24.000.255. We've got the network statement for the next directly connected 172.16.3.0, which is a /30. And there's an neighbor adjacency that's coming up. And we've got a final network statement for another /30, 192.168.10.8. That is the network ID. And I'm going to detail, this is how they're going to show you how to do it in the Packet Tracer activities. I could throw my EIGRP Router ID in here after the fact, right? And let's see what happens when I enter that. And I did that intentionally, right? We waited to set the EIGRP router ID until a neighbor adjacency between router 1 and 2 had formed, and look what happens. If I set or change the router ID, the EIGRP router ID, it will take the adjacency down and bring it all, it takes it all the way down and brings it all the way back up. This is a disruptive change because the router ID is important. These EIGRP routers need to know the router ID of routers from which they're receiving routing updates to prevent loops, right? And again, specifically when we're talking about redistribution, but also here, right? If you get an update that has your router ID in it, well then it's circled all the way back to you. It's a loop. You're not going to install that update, right? You're not going to see that routing update in your routing table. So I set it after the fact. This is disruptive, which is why you want to do it up front. Because I typically, when I open my EIGRP config up, it's typically going to be the EIGRP router ID that I set right away so that I don't forget. And then my passive interfaces. Then I do my network statement configurations. All right, and so we're going to passive, it looks like, and I'm sorry, was that gig 00? Yeah, it's gig 00. So we'll say passive interface gigabit Ethernet 00. We'll say end. We'll do a write mem and save our config. And then we'll come over here to router number 3. And yeah, I did get both of those statements in there. So we'll get into global config. We'll say router EIGRP1. I'm going to go ahead and set the EIGRP router ID. I'm going to practice what I'm preaching here. And then we're going to go ahead and we're going to say passive interface gigabit Ethernet 00. And now I'm going to add in my network statements. But instead of looking at, again, you could look at the diagram up here. Let's say do show IP route. Let's look at the routing table and see if we can come up with what the network statement entries would be. And so the first is going to be 192.168. 1.1.0, and this is a wildcard mask for a /24. And then we've got another 192.168.10.4, which is a /30, and that's the associated wildcard mask. And you can see the adjacency is up there, and that's between router 1 and 3. And then I would say 192.168.10.8, another /30. And that should bring up the adjacency between router 3 and router 2. And let me make sure I got that right, 192.168.0.0.0.3. And so that is correct. And I was wondering if on router 2, did I forget show run section router EIGRP? And I did screw that up, didn't I? I put a 172 in there. Or no, that's actually right, 190. Oh, 192.68. So we get the bonus lab here, right? Router EIGRP, router EIGRP1. And so I can fix it first and say 192.168.10.8.0.0.0.3. And the adjacency comes up between, because the adjacency, when I did 3, I should have seen the neighbor adjacency between router 2 and router 3 come up, and we didn't. And I waited a few seconds, this thinking, man, maybe Packet Tracer's a little slow. As soon as it didn't, I'm like, something's got to be wrong on router 2. And then let's get rid of this 192.68.10.8 network entry, which is not correct. So we'll save our config here, do a quick write mem. We'll say show run pipe to section router EIGRP, GRP1. Now, I could do this if there's multiple EIGRP configuration stanzas, autonomous system numbers configured, you can specify just the EIGRP ASN configuration stanza you'd like to see. Again, if there's only one, you can just say section router EIGRP. So I take a look at that. Everything's good. The activity's at 100%. So let's come down here. They've got some things. Which commands display the neighbors discovered, right? So I could say show IP EIGRP neighbors. Right, and let's see if they've got and they don't have the detail command. Again, if you had multiple EIGRP autonomous systems and you only wanted to see a specific ASN's neighbors, you could specify the autonomous system number. However, when there's only one autonomous system configured, one ASN configured on the router, you can just simply say show IP EIGRP neighbors. Now, all 3 routers should have two neighbors listed. How are the routers identified? They're identified by the address over which the adjacency has been configured. So if I come over here to router 3, we'll switch over to a new router. We'll say I want to save the config here anyway. Show IP EIGRP neighbors, right? So the handle, and that's what the H stands for. And I've always thought that this was kind of odd that they have handle. Now, the handle starts with a numbering of 0. 0 meaning this was the first EIGRP neighbor. 1 is the second EIGRP neighbor relationship. If I brought up a third, it would be 2, and then 3, and then 4. But again, the H stands for handle. And I should probably ask Donnie why they came up with that. Why is it H? Why is it handle? What was the thinking there? Because that has never made sense to me. All right. So this is how we would identify the neighbors with whom we've got adjacencies and the interface out which that adjacency has been established. And you can see here for the 10.9, and if I was to say show IP interface brief, you can see that my address, router 3, is 10. And so the neighbors are identified by their address and the interface out which I get to or am connected to that router via that address. We've got our hold time, which is 3 times the hello timer value. The hello timer value is 5 seconds. So every 5 seconds, there's an EIGRP hello message being sent. Let's see if I've got a debug IP EIGRP. Whoops. Summary. I don't know if we're going to be able to see the packets here. I don't know if we're going to see much because we're not going to be catching the packets. What command displays parameters and other information about the current state of any active IPv4 routing protocol processes? Well, I could say show IP protocols. You can say show IP protocols, and that's going to give me a bunch of information and some very important information. It shows me the passive interfaces on this router. It shows me the networks for which EIGRP is enabled on the interface, and it shows me the K metric values, the composite metric values. Shows me my router ID. Shows me the administrative distance for internal EIGRP and external EIGRP routing information. It shows you the EIGRP AS number, right? So show IP protocols, very important command to be aware of. Now, on router 2, wait, listen, how many routes are sharing the routing information with router, or how many routers are sharing routing information with router 2? Well, it's routers 1 and 3. Where is the information located under? We could say show IP route. You could also say show IP EIGRP topo, this is a command that we're going to get into when we start to talk about successors and feasible successors and computed distance and feasible distance and the feasibility condition. Things that I would highly recommend you dive into the RFC to take a look at. Maximum hop count. Where is that information located? Well, the show IP protocols, I believe, is going to have our maximum hop count of 100, but we could change that maximum hop count all the way to 255 if we wanted to. But defaults, and I was taught this early on with Cisco routing, the defaults with the routing protocols are there for a reason, right? They weren't just arbitrarily guessed at or people throwing darts at a dartboard saying, oh yeah, the hello interval for EIGRP, let's make it 5, right? There are reasons for these things. And typically, unless you have a very compelling reason to change a default, leave it as the default, right? Leave it as the default value. I mean, a maximum hop count of 100 in most environments, that's probably going to do the job, right? Not there, the environments where you're having to consider making your hop count over 100, those are probably going to be, and I don't want to say corner cases, but those are the exception. Typically, the rule is going to be that the default is going to do what you need it to do, right? All right, now the last thing that I want to show you, and this is extremely important, you'll notice we were using the wildcard mask. And the reason that Cisco is going to have you do that is because it makes really great exam questions when they can show you network statements where the wildcard mask doesn't actually match what the dotted decimal subnet mask notation is, or doesn't reflect what the dotted decimal subnet mask notation would be. So I'm going to show you some multiple ways that you can do this. And if you're looking to move on to the lab exam, and again, this is a Cisco best practice, you want to be specific. Specificity is better than ambiguity, right? Especially in router configurations. And so what do I mean by that? Well, here we are on router 1, and actually, I'm sorry, we're going to be on router 8 and 9 when we do this. Here I am on router 8, and let's get into router EIGRP 1. Now, do show run interface serial 000. This is the interface over which it's connected to router 9. We're going to create an EIGRP adjacency. So what's one of the first things I would do? EIGRP router ID 0008 for router 8. I'm going to say passive interface default. And then I'm going to say no passive serial 000. That's the only interface over which we're going to establish an EIGRP neighbor adjacency. So to the network command, if I know the IP address of the interface on which I want to configure and activate the EIGRP routing protocol process, I'm going to say network 10.88.99.8. I'm going to use the specific exact IP address of that interface, even though it's a /24. I'm going to reflect it in the network statement as a /32. Because here's what happens. I'm going to hit enter. And what happens is the EIGRP process looks at the interface on which that IP address is configured, 10.88.99.8. And it says, what's the subnet mask in dotted decimal notation here? Oh, it's a /24. Okay. Well, then that is what I'm going to use, is that /24 when I do my advertisement. So it's not going to advertise a /32 host route. It's going to advertise this /24. But this, in the network configuration perspective, that is how we enable the process on that interface. And then we let EIGRP work its magic and make the determination that, well, it's a /24. So that's how we're going to advertise that. And that's what would end up happening. And the reason that we want to do that is we want to be specific, right? We want to be very, very specific. Now, that's one way that I could have done it. And let's come over here on router 9 and we'll do the exact same thing. We'll get into, and let's say do show run int serial 000. Let's make sure it's ready to go, and it is. And actually, we need to change that, serial 000. Let's say IP address 10.88.99.9 is what we're looking for. We're going to make it a /24. So when I say router EIGRP1, I'm going to say EIGRP router EIGRP router ID 0009. We're going to say passive interface default, and we're going to say no passive on that serial interface because we want the neighbor adjacency to form. 10.88.99.9. And then I'm going to use the quad zeros to be as specific as I can. And take a look at that. The adjacency comes up right away. Now, there's another way to do that. If I pull that out of here, pull the network command out of here, I could also say network 10.88.99.9 and use, and this is on current versions of Cisco iOS, I could use the dotted decimal subnet mask notation if I don't want to hassle with the wildcard mask. Now, and again, you can see it works, right? Because what EIGRP is going to do show run, pipe it to section router EIGRP1. What EIGRP is going to do is it's going to say, oh, he put in the dotted decimal subnet mask notation. I'm smart enough to know that we need the wildcard mask. But if he gave me the subnet mask, the wildcard mask is just the inverse of that. So let me put that in here for the network administrator. And it works like a champ. However, again, I am not a fan of the wildcard mask reflecting the subnet mask and dotted decimal notation. I'm a huge fan of 10.88.99.9. I want it to reflect the IP address of the interface on which the EIGRP process is running, the specific IP. And so, again, this would be considered, again, I've seen this in multiple places as Cisco best practice. And if you're preparing for the lab exam, make sure you are very comfortable with this type of a notation when you're enabling the routing protocol process on the IGP for OSPF or EIGRP and OSPF. The same process can be followed. Make sure you're very comfortable with this from a configuration perspective. All right, well, that is going to conclude this Packet Tracer tutorial on Packet Tracer Activity 2.2.1, where we configured basic EIGRP with IPv4. And again, we're going to go much deeper into EIGRP as we make our way through the material. Thank you guys so much for watching, and as always, I hope to see you in the next video.